Welcome to Physics 102, titled General Physics 2. Physics 102 is the continuation of Physics 101. We will start with study session 1, titled Oscillation. Oscillatory motion or periodic motion is the most common type of motion. Example of an oscillatory motion is the heartbeat of a human being or the swinging of a pendulum clock. All this kind of motion they happens periodic in nature. There are two types of motion that is associated with oscillatory motion, which are circular motion and wave motion. But before we go into these two types of motion, we fully explore elasticity. In General Physics 1, you have learned about elasticity. But in order to explain the concept of oscillatory motion, you will be introduced to the basic concept of elasticity before, and then we will move into the concept of periodic and simple harmonic motion. At the end of this study session, you should be able to explain the concept of elasticity, you should be able to explain the term periodic motion, and you should be able to describe a simple harmonic motion. In this slide, you can see a mass spring in which a bulb of mass m is attached to it. In this spring, when an external force is applied on this body, since this body is not free to move, there will be a relative displacement of that body. But due to the elasticity of this body, the body will regain its original position. This is called a deforming force. So a deforming force is an external force which, when applied to a body, causes change in the physical properties of that body, such as the length, the volume, or the shape of the body. For example, when a bulldozer pushes a car into a wall, the car will not move, but you will notice a change in shape of that car. A change in shape is due to the force that was exerted on that car. This force is called a deforming force. So a body which experiences such a force is called a deformed body. When deforming force applied to a body is removed, the body regains its original state due to the force developed within the body. This force is called restoring force. So we can define restoring force as the force which enables a body to regain its original state when the external force acting on such body is removed. And this kind of body in which both deforming and restoring force acts upon is called an elastic body. So we can define elasticity as the ability of a material to regain its original state when the force being applied to it is removed. Stress and strain. First, talk about stress. In a deformed body, restoring force is set up within the body, which tends to bring the body back to its normal position. So the magnitude of this restoring force depends upon the deformation that was caused when such a force was applied on it. We calculate stress of such a body by dividing restoring force by area. So the unit of stress is Newton per meter square. But strain on its own, when due to the application of deforming force, when the length, the volume, or the shape of that body changes, such a body is said to be strained. So we calculate strain with this formula, change in dimension divided by the original length. Strain is the ratio of two similar quantities' lengths. Therefore, strain has no unit. Hooke's law. English physicist named Robert Hooke between the year 1635 and 1703 put forward a relation between the extension produced in the wire and the restoring force developed in it. And the formula or the law he postulated was called Hooke's law. So Hooke's law states that within the elastic limit the strain produced in a body is directly proportional to the stress that produced the strain. So if stress and strain is directly proportional, we can say that stress is equal to a constant times strain. So this constant is known as modulus of elasticity, represented by K. So modulus of elasticity is calculated by dividing stress with strain. So an elastic modulus, always represented as E, could be defined as the ratio of stress to strain of a material. Elastic modulus and strain, elastic modulus and stress has the same unit, which is Newton per meter square. Now, since we have explained the concept of elasticity, we can move on by explaining periodic motion. Periodic motion is defined as a motion that repeats itself at regular time interval, such as the motion exhibited by a guitar string or by an object on a spring moving up and down. When you pluck a guitar string, the resulting sound has a steady tone and lasts a long time. Each successive vibration of the string takes the same time as the previous one. That means it is within a regular interval. The time to complete one oscillation in periodic motion remains constant, and it is called period, represented by T. And since it is time, it will always be measured in seconds. So, for periodic motion, frequency is the number of oscillations per unit time. The unit of frequency is cycle per seconds, and professionally it is termed as Hertz. Now let's talk about simple harmonic motion. SHM, an abbreviation for simple harmonic motion, is the name given to oscillatory motion for a system where the net force can be described by Hooke's law, and such a system is called a simple harmonic oscillator. The oscillation of a system in which the net force is described by Hooke's law is of utmost importance because they are very common. They are also the simplest form of oscillatory system. One special thing that is so significant but about simple harmonic motion is that the period T and the frequency F of a simple harmonic oscillator are independent of amplitude. What is an amplitude? An amplitude is the maximum displacement from equilibrium. The units of amplitude and displacement are the same. A simple harmonic motion is the motion of a particle whose acceleration is proportional to its displacement from the fixed point and is always directed towards that point. Mathematically, acceleration A is calculated as minus omega square x. The two important factors that affect the period of a simple harmonic oscillator are 1. How stiff is the body of the oscillator, and 2. The mass of the oscillatory body. The period is related to how stiff the system is. A very stiff object has a large force constant K, which causes the system to have a smaller period. For example, you can adjust a diving board stiffness. The stiffer it is, the faster it vibrates, and the shorter the period. Thank you for this.